Okay, so last week we did the dancing straw practicum. We charged up our insulating material, our styrofoam. We had our metal pie tin, our metal encased straw with foil, and then ourselves the large conductor. We set this down. The straw goes shooting outward. I bring my hand in, and we get this rattling back and forth, back and forth, back and forth, back and forth. Eventually it slows down and comes to a stop. We can see it slowing down and eventually coming to a stop. All right, so we're about stopped there, and all we had to do was lift it up off of our insulator, and we get the same effect. It got attracted in, touched, repelled, and the rattling again. And what I tried to do, one last step, just to maybe show you some similarities between stuff we've already done. Looks like it's over. All I have to do is bring my styrofoam back in, and it repeats. So that was the question that you were tasked with last time, is explaining everything that went into that exam. And so let's take a look at all of the steps that we saw in that last video. If you haven't seen the video, search the dancing straw and watch the in-depth video on all the things that take place and all the materials that we're using. When it comes to explaining what's happening, sometimes it's just as important to understand what isn't happening. So what I'm going to do is I'm going to get rid of our little apparatus here for just a second. And what I'm going to do is I'm going to bring in our plain old pie tin that we had used for the Electric Forest Lab. And what we're going to do is we're going to take a look at what happened when we went through this one. There was an explanation video already previously done, but let's take a look at not just what happens here, but what doesn't happen. So when we take just a plain pie tin and set it down on top of our pink styrofoam, we placed it down, we would reach in, listen, shock, lift up, shock, down, shock, up, shock, down, don't touch the rim, right back up, no shock, no shock, shock, shock. So what I'm seeing here is proof that when I set this down, charges are not going from the styrofoam up into the pie tin. If that was the case, all I'd have to do is set it down, lift up, and I should get a shock. Down and up, shock. Not happening. Down, touch, shock, shock. So what we're seeing here is that charges are not being transferred from the styrofoam to the pie tin. Now, just swapping these things out here, I still have a pie tin. There's no change there. So when I set this thing down, right, and this thing goes through its process over here, same thing. I'm not getting a charge going from the styrofoam up to the pie tin. If that were the case, I should be able to lift this up and rattle, and that's certainly not happening. I have to set it down first, go through the rattling process, and only then can I lift this up to go through the rattling process again. So what we're seeing is that we are not getting a transfer of charge from the styrofoam up to the pie tins, because this is an insulator, this is a conductor. We're not going to get a smooth, easy transition of charges. Any conduction happening is very, very minimal. So again, knowing what's not happening is part of the key idea. So we're not getting a transfer of charge from the styrofoam up into the pie tin. Now at this point, I think we're all very aware that when you take the rabbit fur and you rub it back and forth across your styrofoam, the styrofoam gains those negative charges, which means that our rabbit fur is going to end up with a positive charge because it has given the electrons that it has to the styrofoam. So we end up with a negative piece of styrofoam. We end up with a positive fur. When I hold those two together, there's a good, strong attraction between the two of them. It's one way we can test to make sure we've charged it up properly. So we scroll down at our next slide here. So what I have is I have our pie tin. Our pie tin has in my picture 8 positives. Those positives are locked in place. They represent the structure. I have my negative styrofoam, which is going to remain negative the entire time. We already saw that we don't lose any of those negative charges. I'm going to have my green piece of straw, which is a conductor over here. I'm going to have my hand. My hand is a ground, so I could go so far as to draw a little grounding symbol inside my hand. So step number 2 is us placing this thing down on our styrofoam. Well, if I place it down on the styrofoam and no charges transfer over, I do, however, have the presence of this big negative source. Because I have this big negative source, it is going to have an effect on my pie tin. So my pie tin is going to have, looking at my picture, my pie tin is going to need 8 negative signs, but those negative signs can be drawn anywhere inside this material because it is a conductor, which means I can go through and put in 1, 2, and what I know is that these negatives are going to be able to shift anywhere, and because there is this big negative pink material down below, these 8 minus signs are going to be driven upward. The word we would use is polarization. Our pie tin becomes polarized. Our styrofoam remains negatively charged. So when I am done, there are my 8 negatives across the top. My pie tin is still neutral. However, it has become polarized. I have a negative end at the top. I have a positive end at the bottom. I have 2 opposite ends that are going to both behave as if they were charged, even though the whole thing is actually neutral. Now, when we did our electrophorus lab, we just brought in our hand, and our hand removed those 8 electrons. Maybe it's only 6 or 7 electrons, but it removes a bunch of those electrons in the form of an electric shock into my hand. I'm so large that the few electrons that I take from this tiny little pie tin pretty much unaffecting me. I am so large I can take a few of those extra electrons and I am still overall neutral. This time, however, what we're going to do is we're going to bring over our neutral. I said neutral, it doesn't look neutral yet. I brought over my neutral straw. The straw is wrapped in foil, which means it is a conductor. So that straw piece is very small when I compare it to the rim of the pie tin. The rim of the pie tin is overall negative. The whole pie tin is neutral, but the rim itself is negative, which means that my negatives, the 2 that I need to draw, are going to be repelled from the rim. And what do I notice? I notice that the negative rim and the positive end of my straw are close. Strong attraction. The negative and the negative, there is a repulsion, but it's further away. It is going to be weaker. And so this right here will be attracted in towards the left. What happens when this comes in contact? I have one large conductor, a pie tin, and my little, as it is here, green straw. When conductors touch, they behave like one large conductor. They're going to share their charge relative to their size. The rim of the pie tin is much bigger than the straw, so it's not going to be a 50-50 share, but one of these negatives is going to shift over. Now, what charge is my green straw? What charge is the rim of my pie tin? With those ideas in mind, I recognize this is going to now be repelled away. This is a negatively charged straw. My hand is a conducting neutral. I know Rule 4 says that this negative and this neutral should attract, just like when this was neutral, it would attract. So make sure you understand how it is that this negative would attract a neutral hand. When this comes in contact with my hand is a conductor, the straw is a conductor. We are going to share our charges. The larger object gets most of them, so that means that this extra charge it has is going to jump into my hand. Now, it doesn't matter which one it is, so this one right here is going to jump into my hand. My body's going to absorb it. I do not take all of them. That's not what a ground does. I'm the ground. The ground neutralizes things. So I'm not taking all the negatives. I'm taking just enough to make this neutral again. And as soon as I do that, what has happened? This is right back to where it was before. A neutral straw, a negative rim. And so what happens? This is going to swing in again, contact. What's going to happen? It's going to repel out, contact. What's going to happen? It's going to go back and forth and back and forth and back and forth. How would my picture change every cycle? Well, the next cycle goes through, that negative, gone. The next cycle goes through, gone. Try that again, gone. The next cycle goes through, the next cycle goes through, gone. And as you can see, what's happening to the top of my pie tin? Why will this eventually stop rattling back and forth? Now, when I'm done with the rattling back and forth, what are we going to do next? We're going to take this pink styrofoam, we're going to move it up. Whoops. We are going to move it out of the way. So this is now gone, no longer part of it. What do I have here? Whatever remaining negatives I have, they're going to spread out. If I say that all 8 are gone, fine. I'm going to say that only 4 were taken away. So the 4 I have left are now going to spread out. Look at my picture. What charge does my pie tin have? The overall charge hasn't changed. If I bring this back over, what's going to happen? This thing's going to get polarized again. Those negatives go to the top again. But the overall charge that it has remains the same. I've gone through and taken away 4 negatives with my bouncing straw. I take the styrofoam away, and now I have an overall positive. Every section I look at over here, I've got 2 pluses and 1 minus. Positive side, positive top, positive bottom. The few negatives that I have spread out evenly, which means the overall net positive charge spreads out evenly. So if I were to place a positive pie tin near a neutral straw, those positives are going to attract my negatives, and now what happens? We end up with an attraction flying over. We get contact. I have a big positive and a little neutral. They're going to share the 1, 2, 3, 4, 5, 6. They're going to share the 6 negatives that they have between the two of them. The bigger object gets more. So I can say that one of these jumps over. Maybe I even go with 2. I'm going to stop with just 1. So now this has taken one of those negatives away. It's still positive. My green is now positive. So now we recognize why it is that once this thing is lifted back into the air, it touches, it repels. And what does my hand do to any charged conductor? If I am the ground, I neutralize. This thing will get neutral. This isn't the same exact negative that I had before because there's a bazillion of them in my hand. So some random negative leaves my hand and now it's neutral. There is absolutely no reaction now between my hand and the straw. There's no attractions, no repulsion, but there is an attraction to the pie tin again. And it happens again and again and again. And what happens every round? I get one of my negatives back. And I get one of my negatives back, etc., until eventually I bring back all the negatives. And we are right back to where we started. Another way we can look at this is if I take our pie tin apparatus and set it down, what if I didn't reach in and allow the straw to rattle? What if I just reached into this side, just like our previous lab, and shock? Lift up and rattle, 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 until eventually it stops again. And I can go back down here and I can either go with a rattling, and eventually it stops. Okay, now lift up instead of going with the rattle, shock. So I'm seeing the similarities between our electrophorese lab and our dancing straw. I can replace the rattling of the straw with a single shock. I already shocked myself once. I can set this down and I can choose rattling or shock. Rattling, I didn't let it finish, or shock. I can start with a rattle, don't let it finish, shock. So I'm seeing the similarities between the rattling back and forth, back and forth, back and forth, and a singular shock. So effectively, what does this rattling, what does it represent? The world's slowest shock. Instead of one big jolt of electricity jumping from the rim into my hand, it comes in little teeny tiny waves as the straw slowly brings the charges over to my hand. And then the straw slowly takes the charges from my finger. I'm the ground, I have a ton of charges. Takes the charge from my finger and takes it back to the pie tin, little teeny tiny bits at a time. So hopefully that makes sense. If you have to go back to week 4.2 to revise your explanation of the practicum, great, go ahead and do that. You can submit as many times as you need to.